Now quickly, the surveyor is at point X. The surveyor is at point X, and he sights a pole Y due east of him. He sights a pole Y. That means Y is going to be directly on the same horizontal level as X. That's a pole Y due east of the surveyor at X. Now, he sights a pole Y due east of him and a tower Z of a building on a bearing of 46 degrees. Let this be the tower Z of the building. It's on a bearing of 46 degrees. It's on a bearing of 46 degrees. So this is Z. This is the tower Z. Now, after walking to a point W, a distance of 180 meters in the southeast direction, let's show that southeast direction. Let this be the point W where you walked to, and that's a distance of 180 meters from X. W is 180 meters from X. Now, if W is in the southeast direction, that means this will be 45 degrees and this will also be 45 degrees. Now, he observes the bearings of Z and Y to be 337 degrees and 50 degrees respectively. That means the bearing of Z from W is 337 degrees. That's going to be somewhere around there. And the bearing of, that's going to be somewhere around there. That's the bearing of Z from W, and it is 337 degrees. And the bearing of Y from W is 50 degrees. Let me show that this way. That's the bearing of Y from W. The bearing of Y from W, and it's 50 degrees. 50 degrees. Now the question A says calculate correct to the nearest meter. Roman figure 1, length XY, and Roman figure 2, length ZW. So I'm doing a Roman figure 1 first. How do you find length XY? First of all, if this is 50 degrees, then this will also be 50 degrees. They are both alternate angles, and that simply means this angle will be this angle will be 40 degrees. Now, if I know that that's 40 degrees, 45 degrees plus 40 degrees plus the whole of this angle is 180 degrees. So that simply means this angle is 95 degrees. And now I have everything I need to find the length XY. So length XY over sine, I'm looking at triangle XYW. Length XY over sine 95 degrees is equal to length XW, which is 180 meters, over sine 40 degrees divided by the sine of this angle, sine 40 degrees. And that simply means length XY is equal to 180 times sine 95 degrees over sine 40 degrees. Sine 40 degrees. And let's see, what does that give us? What do we have? 180 sine 95. 180 sine 95 divided by sine 40. Sine 40 degrees. And that's 278.965. That's equal to 278.965 meters. And they said we should give our answer correct to the nearest meter, and that's simply 279 meters. So we go straight to Roman figure 2. That's Roman figure 2, which says find the length ZW. So let's go back there. How do we find the length ZW? If this is 46 degrees, then this will be 44 degrees. That's correct. 90 minus 46 is 44 degrees. That simply means the whole of this angle is 89 degrees. 89 degrees. Now that I know that, what else do I need to be able to find the length ZW? Okay, if this is 46 degrees, this angle will also be 46 degrees. They are both alternate angles. And I know that, okay, let's see, if the bearing of Z from W is 337 degrees, that means the whole of this angle is 337 degrees, which simply means this small angle will be 360 minus 337, and that's 23 degrees. So this angle 23 degrees is the same as this angle. They are both alternate angles. I hope you can see that. That's also 23 degrees. So that means the whole of this angle is 69 degrees. Yeah, that's 69 degrees. So what else do I need? Okay, we can now go ahead and find the length ZW. So that simply means length ZW divided by sine 89 degrees. Yes, 89 degrees divided by sine 89 degrees is equal to length XW, which is 180 degrees, divided by is equal to length XW, which is 180 meters, divided by sine 69 degrees. I'm looking at triangle XZW now. So length ZW over sine 89 degrees is going to be equal to length XW over sine 69 degrees. That's a sine rule. So that's length XW, which is 180 over sine 69 degrees. And that simply means length ZW is equal to 180 times sine 89 degrees divided by sine 69 degrees. And let's work that out very quickly. 180 sine 89 degrees divided by sine 69 degrees. Sine 69 degrees. And that's equal to 192.777 meters, which is to the nearest meter 93 meters. Which is 93 meters to the nearest meter. Yeah, that's 193 meters rather. And that's it, very, very simply. So let's go to the second question. Let's go to it. I'm trying to see to be sure I didn't make any mistake. Yes, okay. That's 80, 90. Okay. So let's go to the second question, which says, that's question B. Question B. If N is on XY, if point N is on the line XY, such that XZ is equal to ZN, find the bearing of Z from N. Okay, let this be the point N. Let this be the point N. So N is on XY such that XZ is equal to ZN. I have to join Z to N. That's ZN. Now we are told that XZ is equal to ZN. So if that's the case, if XZ is equal to ZN, that simply means triangle XZN is an isosceles triangle, and that simply means if this is 44 degrees, this angle will also be 44 degrees. Base angles of an isosceles triangle are equal. Now the bearing of Z from N is therefore the whole of this. That's the bearing of Z from N. Let me show that again. The bearing of Z from N is the whole of this. That's the bearing of Z from N. And that is 270 plus 44. The bearing of Z from N. Bearing of Z from N. Bearing of Z from N equals 270 plus 44, which is equal to 314 degrees. And that's it, very, very simply. All right, thank you very much, and I'll catch you in the next. Bye-bye.